Experimental verifications of turning and walking gaits for a 2-actuated spoke wheel robot. IMPASS, Intelligent Mobility Platform with Active Spoke System. Developed at the Robotics and Mechanisms Laboratory at Virginia Tech, IMPASS is a novel robotic system with high mobility that uses a pair of actuated spoke wheels. Each of the spokes can be individually actuated in and out of the hub to act as legs. In previous work, we have demonstrated its motion planning strategies, such as climbing high obstacles using deliberative behavior, and walking over changing terrain using reactive behavior. Only one spoke touches the ground for each left and right actuated spoke wheel for the 1-1 straight walking gait. With no slip assumption at the contact point, this provides 2 degrees of freedom so the trajectory of the body can be shaped in the sagittal plane. Here, the body traces a straight horizontal line. For the 2-2 straight walking gait, there are 2 spokes touching the ground for each left and right actuated spoke wheel. This creates a closed-loop mechanism where the center of the hub needs to follow a circular arc trajectory in order for the foot not to slip. Unlike other wheeled vehicles which use Arckerman or differential steering, IMPASS can implement novel turning gaits even though the left and right hubs rotate with the same angular velocity. Through changing the effective wheel diameter by moving the spokes, IMPASS can turn to the left or right by using the steady-state turning gait. However, when IMPASS needs to transition between gaits, it must go through a transition step in order to prevent slip at the foot. Here, a skew transition is used to change from one gait to another. This video shows the 1-1 straight walking gait, a skew transition for straight walking to steady-state turning, and a steady-state turn. This video shows the operation of IMPASS by joystick control. IMPASS can easily change its body's height, roll, pitch, and yaw, besides moving forward and backward. However, when utilizing joystick control for free-form motions, the operator is not bound by strict kinematic constraints and is relying on the compliance of the spokes. When turning, the spoke twists about its own axis due to friction with the ground. When walking higher and not observing strict kinematic constraints, the spoke has a tendency to pop due to the sudden release of the potential energy stored in the compliant spokes. This video has been brought to you by RoMeLa, the Robotics and Mechanisms Laboratory at Virginia Tech. The authors of this video would like to thank the National Science Foundation for their continued support for this project.